Device is hub. Fine. Now guys, most important thing. You always represent hub like this with a single arrow. Any issues? No. Now what I was discussing with you, that in case of hub, we have a bus. How many of you are from EC, electronics department? Those people are familiar with bus. What is a bus? I think it's a hardware connecting ports. Bus means no, I'm not saying about bus topology. Yeah, something like bus. I don't know about it. Oh yaar. आगे लाइट चलाना यार. Fine. Now, if I say a hub is connected with another hub, and a guy is sitting here. He want to communicate with a guy who's sitting here. He will send a message. Agree? What hub will do? Broadcast. What this guy will do? What this guy will do? He is forwarding a broadcast and the broadcast is reaching till this point. This is my one broadcast domain. It means it doesn't matter I am connecting a single hub or I am connecting multiple hubs. That will result in a single broadcast domain. What do you mean by broadcast domain? One to all. What do you mean by domain? In a specified area. My message is still traveling from one to all in this whole area. So this is my one broadcast domain. This thing is clear? Any issues? No. Next thing. Hub is having one collision domain. What do you mean by this thing? See, this is a hub. How many ports are there? Let's say there are 8 ports. What do you mean by port? This thing is clear to you? Port type will always be, it can be Ethernet. We will discuss about it. What is Ethernet? Wait for some time. Fine. Now, I am connecting a computer here also. I am connecting a computer here also. See, what I just told you. When one guy will send, all other will receive. Fine. This guy is sending, all other are. It means at the same time, none of them can send. Agree or not? Agree or not? Now you will say, sir, we are not foolish. How? First I have to prove the question. The question is, what question you can ask from me? Sir, let's say we are 8 people connected to a hub. We all are accessing internet. Fine. How this guy will get to know that his computer is receiving and he cannot send at the same time? What I am saying? If A is sending data, B is receiving. how user sitting here will get to know that I am receiving and I don't have to send at the same time. Question is clear to all of you? मैंने क्या बोला? A send कर रहा है, गूगल पे जा रहा है A का डेटा, फाइन. अब A का डेटा जब गूगल पे जा रहा है तो सबके पास भी जा रहा है. रूल इज 1 to all. तो यार B को भी कम्युनिकेट करना है. B ऑल्सो वॉन्ट टू कम्युनिकेट. फाइन. हाउ B will understand? How the user will understand that I don't have to send at the same time? See, user will never understand. Who will understand? Computer. Who will understand? Computer. Fine. See, actually what happens, whenever you connect your computer to a device, let's say this device is hub. What computer will do? Computer will negotiate one thing with the device. What it will negotiate? What it will negotiate? Duplex mode. It means computer will send a packet to the device that on my side duplex mode is full. Now on the other end device is hub. On the other end device is hub. Hub will never reply for the message. Agree or not? Because hub is not having an operating system. Agree? Now computer will get to know that I am connected to a hub. So computer will change its mode from full duplex to half duplex. Now when computer knows that my port is running half duplex, it will start a protocol at its end. Which protocol? CSMA CD. Carrier sense multiple access collision detect. What is the use of this protocol? See, this protocol will check that my link is idle or not. If link is idle, only then I can send data. If link is not idle, I cannot send data. If link is idle, then I can send data. If link is not idle, I cannot send data. This thing is clear? So, what will be the whole process? I am a computer, I am connected to a hub. As I am connected to a hub, I try to negotiate my duplex mode with the hub. Because I don't know that on the other end, the device is hub. I have to check whether I am connected to hub or whether I am connected to a switch. This thing is clear? Now the computer will negotiate, but computer will not get a reply. So computer will understand I am connected to a hub. It means in which mode I have to work? In half duplex. Whenever computer will work in half duplex mode, it will run a protocol at its end. The protocol is CSMA CD. Carrier sense multiple access collision. What is the use of this protocol? This protocol is used to check that the link which is connected to the hub is idle or not. Now see. Go back to the previous diagram. A is connected to the device. What I told you, A is sending data to Google server. Fine. A is sending data to Google server. Google server is receiving the data, but side by side, all the users who are present in the same broadcast domain are also receiving the data. Agree or not? Now, B is also receiving the data. It means B knows that my link is not idle. My link is not. It means B cannot send at the same time. So this is how CSMA CD will prevent collisions. Yes, it is preventing collision. If B will send at the same time, what will happen? There will be collision. Your network performance will be low. This thing is clear? तो हुआ क्या? A सेंड करेगा डेटा, फाइन. B भी रिसीव कर रहा है, C भी रिसीव कर रहा है, D भी रिसीव कर रहा है, E भी रिसीव कर रहा है, फाइन. तो जैसा कि मैंने आपको बताया, जब मैं बी को हब के साथ कनेक्ट करूंगा, बी क्या करेगा, सबसे पहले डुप्लेक्स को नेगोशिएट करेगा। कंप्यूटर अपने एंड से मैसेज भेजेगा किसको, हब को, भाई मेरा डुप्लेक्स मोड क्या है, फुल। आई एम रिपीटिंग द सेम थिंग, माय डुप्लेक्स मोड इज फुल। हब कहेगा भाई मेरे को तो इस मैसेज के बारे में कुछ पता ही नहीं है, क्योंकि मेरे पास तो कोई ऑपरेटिंग सिस्टम है ही नहीं। हब कोई रिप्लाई नहीं देगा, कंप्यूटर समझ जाएगा मैं किससे कनेक्टेड हूं, अपने मोड को क्या कर लेगा, हाफ डुप्लेक्स करते ही कंप्यूटर के एंड पे एक प्रोटोकॉल काम करने लग जाएगा। प्रोटोकॉल का नाम क्या है, CSMA CD। उसका काम क्या है, सिर्फ चेक करना कि मेरा जो लिंक हब से कनेक्टेड है वो आइडल है या नहीं। तो CSMA CD अब बी पे भी काम कर रहा है, सी पे भी, डी पे भी और ई पे भी, सब पे काम कर रहा है। सबको पता है हमारा लिंक अभी आइडल नहीं है, तो आप अपने एंड से तो क्लिक कर दोगे, लेकिन वो डेटा किस पे रहेगा, होल्ड पे। जैसे ही ए का ट्रांसमिशन खत्म होगा और सबसे पहले जिसको पता चलेगा, बी को, सी को, डी को या ई को, कि भाई मेरा लिंक क्या हो गया, आइडल, तभी वो क्या सेंड कर देगा, डेटा। व्हाट आई एम सेइंग, एट द टाइम बी, सी, डी और ई विल गेट टू नो दैट माई लिंक इज आइडल, दे विल स्टार्ट सेंडिंग डेटा। नाउ here comes the point that there is a chance of collision, that B and C are getting the information at the same time that their link is idle, so they will both send at the same time and there will be collision. That's why when you are using hub in your network, performance is low, because many devices thinks at the same time that their link is idle and they send data at the same time, and because of that what happens, collision. This thing is clear. Now one collision domain means these guys are having only one way to travel. It means hub always works in half duplex mode. It can never work in, because two cannot send and receive at the same time. How it will work in full duplex mode? This thing is clear. Shall I move on? Now if I discuss some points about hub, first thing is hub is having one broadcast domain, second is hub is having one, third is hub works in, fourth is, fifth is, see, protocol never works on hub, it works on computer. Protocol is CSMA CD. Any issue to anybody? Now guys, let us discuss one thing. This is one computer, this is hub, this is second computer. If this guy A has to communicate with B, what A needs? A needs MAC address of B. A will send out a, what hub will do? Broadcast. This thing is clear to all of you? You want to check this thing? This is guy A, this is guy B. I have connected them through a hub. One more guy. Fine. What I will do, I will assign IP address to the computers. Let's say 10001 एंड सबनेट मास्क। अब तक हमें डिफॉल्ट गेटवे के बारे में नहीं पता, वी डोंट नो अबाउट डिफॉल्ट गेटवे, सॉरी। 10.0.0 10.0.0 fine, they can communicate, yes or no? Now what I told you, if this guy has to communicate with this guy, he has to generate a ARP. He will send the ARP, it will be received by hub. What hub will do? Broadcast. Agree? Any problem? Now the guy will reply, he will get the MAC address. See, the reply is also broadcasted. This thing is clear? It means in case of hub, request is broadcasted and reply is also broadcasted. This thing is clear? Next thing, I will open ARP table of this guy. ARP minus, I am having the MAC address. Agree or not? See, he is having the MAC address of 10.0.0.1. This thing is clear? Because it has, this guy has only communicated with 10.0.0.1, not with 10.0.0.3. Fine. Now, what I want to show you, this is not ARP, this is actual data, ping. This is not ARP, this is not broadcast data, this is unicast data. Fine. You can check here. Source IP is, destination is, source MAC is also decided, destination MAC is also decided. But what hub will do? Hub will still broadcast. It means it doesn't matter the traffic is broadcast or the traffic is unicast. What hub will do? Always broadcast. This thing is clear? Any issues? Ten zero zero for next computer. 10.0.0.5. Now see guys, this guy has to communicate with this guy. He will generate a ARP. We will take it like this. Successful. All can communicate with everybody. Any issue? No. What I want to show you. This guy is communicating with this guy. He is generating a ARP. See. Broadcast. 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 Reply is also broadcast. He will get the reply. Now he is sending actual data. Actual data means ping, ICMP traffic. Fine. Broadcast. Broadcast. Reply is also. Everything will be broadcast. This is one broadcast domain. Fine. Any issue? No. Now guys, problems with hub. Just think like, A guy is sitting here. Fine. He is sending a message. The information present in the message is important. Very important. Very confidential. And here is one more guy. One more guy. One more guy. This guy want to send this information only to this guy. Is it possible in case of hub? No. It's not possible. This is the structure of hub. Fine. Like this, ports will be there. Fine. It means I need a device which can perform I am not saying which will not perform broadcasting. What I am saying is I need a device which can perform, because broadcast is necessary. Why it is necessary? Because of ARP. Because of, what do you mean by ARP? What is the use of ARP? To know if the device will not broadcast, I cannot resolve ARP. I will never get to know about MAC address of the destination. It means my concern is to have a device which can perform both broadcast and hub was just doing broadcast. This thing is clear? How it will work? Or first of all, which is that device? That device is switch. This thing is clear? See, one thing, if you have noticed, okay, let us discuss one thing now before discussing about switch. Hub is used to make communication possible between yes. Why not different network? I assign this guy IP address of which network? 20's network. Fine. Now I want to make communication possible between them. They are communicating? No. Why? That's fine. This is a single broadcast domain. But why they are not communicating? What's the issue? See, try to understand a simple thing. A guy can only generate a ARP for a IP which present in its own network. A guy can only generate for a IP who is present in its own. You cannot generate ARP for a IP which is not present in your network. This is the behavior of computer. Computer cannot generate ARP for a IP which is not present in its own network. This thing is fine. यार ये फर्स्ट ऑक्टेट और लास्ट ऑक्टेट क्या होता है? मैंने यार नेटवर्क की बात की है। नेटवर्क किससे डिसाइड होता है? सबनेट मास्क से। मैं /24 लेता तो मैं दूसरी तरह से डिफरेंशिएट कर सकता था। इफ आई यूज /24 एयर, मैं 10 का ही नेटवर्क ले लेता और फिर भी डिफरेंशिएट हो जाता, दो डिफरेंट नेटवर्क हो जाते। यार ऐसा क्वेश्चन मत पूछा करो, दिल दुखता है। मैंने बोला सर, अगर जिस आईपी से मैं बात करना चाहता हूं वो मेरे नेटवर्क में एग्जिस्ट नहीं करती तो मैं उसके लिए आर्क जनरेट नहीं करूंगा। तो 10 वाला बात किससे करना चाहता है? 20 से। 20 वाली 10 वाले के नेटवर्क में एग्जिस्ट नहीं करती तो 10 वाला कभी उसके लिए आर्क जनरेट नहीं कर सकता। ठीक है जी। तो अब आप कहोगे सर जब डिफरेंट नेटवर्क में कम्युनिकेशन होता है फिर होता कैसे है? हाउ द डिवाइसेस विल कम्युनिकेट इन डिफरेंट नेटवर्क देन इफ 10 कैन नॉट जनरेट आर्क फॉर 20? We will discuss it when we will discuss about router. So hub is a device which is used to send traffic in the same network. Fine? This thing is clear? Yes. करके नहीं देखा यार मैंने कभी। क्यों? आपके दिल में आई बात, आप ट्राई कर लेना। Fine. So now we will discuss about switch. See, first property switch is having. It is having a operating system. It means he can understand second things. It can take third thing. He can build forwarding table. What do you mean by forwarding table? Forwarding table means a address table in which there will be a mapping. On the basis of that mapping, switch will forward the information. This thing is clear? So what are the three functions, three main things about switch? First, he is having an operating system because of which it can understand. Second thing, it can take decisions and it can build a forwarding table on the basis of which it will take decisions. How? We will discuss it now. This is switch. A is connected. Here who is connected? B. First thing, this guy will send a message for what? This guy will reply, yes. My port is also working in which mode? Duplex. So you can work in which mode? Duplex. Always keep one thing in mind. Port of switch is in auto state. In which state? Auto means negotiate. If the computer will say I will work in half duplex mode, switch will say I will also work in. If the computer will say I will work in full duplex mode, switch will say I will also work in full duplex mode. So switch port will work in which mode? Auto. In which mode? Auto means negotiate. All of you know the meaning of negotiate? Negotiate means I will be willing to the thing that is running on the other side. जैसा आप कहोगे मैं वैसा मान लूंगा. हाँ जी. पीसी ट्राई करता है सबसे पहले फुल डुप्लेक्स बनाने की, फिर ट्राई करता है हाफ डुप्लेक्स बनाने की. कंप्यूटर विल फर्स्ट ट्राई टू फॉर्म अ full duplex connection, then try to form a half duplex. If full duplex is not successful, fine. अब हमें बात करनी है, नाउ वी हैव टू डिस्कस हाउ स्विच विल वर्क. So this is our switch. A is connected, B, C, let's say D, let's say E. First thing, switch is having an operating system. Second thing, switches also have one BD. One BD means one broadcast domain. Second thing, per port CD. Per port CD means if there are 5 ports on this switch, how many collision domains are there? 5. It means all computer have their own ways. It means in which mode switch will work? Full duplex. This thing is fine. Now, how switch will make forwarding table? Let's say this is the forwarding table of switch. This guy is forwarding some information. Just try to understand the concept. Concept is, if A is communicating with C, if I am saying A is communicating with C, what does it mean? It means A already know about MAC address of C. It means in our table of A, we have MAC address of C. Fine. Now, source will be A, destination will be C. Now, how switch will work? Look here. This is port number 1, port number 2, 3, 4, 5. Now, switch will receive data on which port? Port number 1. When switch is, bhai udhar dekhna. When switch is receiving the data, switch will learn source address from the data. What switch will learn? Source is A. Switch will make an entry in its table that to my port number 1, one device is connected whose MAC address is A. स्विच ने टेबल कैसे बनाई? स्विच ने आते हुए देखा डेटा कौन से पोर्ट पे रिसीव हुआ? पोर्ट नंबर 1 पे. पोर्ट नंबर 1 पे जो डेटा रिसीव हुआ उसमें सोर्स मैक क्या है? ए. मतलब डेटा सेंड कौन कर रहा है? ए. इसका मतलब इस पोर्ट पे कनेक्टेड कौन है? ए. इतनी एंट्री किसने बना ली? स्विच ने. स्विच मेंटेन्स है एंट्री अकॉर्डिंग टू द सोर्स मैक एड्रेस फाउंड इन द डेटा. दिस थिंग इज क्लियर. स्विच ने सबसे पहले क्या चेक किया? सबसे पहले क्या चेक किया? सोर्स मैक. सोर्स मैक को कहां इंस्टॉल किया? अपनी मैक एड्रेस टेबल में. किस टेबल में? फर्स्ट ऑफ ऑल स्विच चेक्स द source MAC in the data, and where that source MAC is installed? In MAC address table. Now switch will check destination MAC. Destination MAC is C. Again switch will check this destination MAC address in its MAC address table. Do we have an entry for C? Do we have an entry for C? No. What switch will do? What switch will do? Broadcast to this guy also, to this guy also, to this guy also, and to this guy also. It means we can conclude one thing from here. What we can conclude? That if switch does not know about destination MAC address, switch will broadcast. Switch will broadcast. स्विच को अगर डेस्टिनेशन मैक एड्रेस के बारे में नहीं पता होगा, या मैं कहूं स्विच की टेबल में डेस्टिनेशन मैक एड्रेस के लिए एंट्री नहीं होगी, तो स्विच क्या परफॉर्म करेगा? ब्रॉडकास्ट. एनी इश्यू टू एनीबडी? कोई इश्यू किसी को? ब्रॉडकास्ट सबके पास गया. एवरीवन विल रिसीव द ब्रॉडकास्ट, वेदर इट इज बी, सी, डी और ई. वी आर कम्युनिकेटिंग विद C. C will receive the broadcast. Now C has to reply. When C will reply, source will be C, destination will be A. Clear? Now C will send the data on which port? Port number 4. Switch will maintain a entry that on port number 4 who is connected? C. Now switch will check destination MAC address. Destination MAC address is A. Switch is having entry for A. A is connected to port number. Switch will send data out of port number 1. It will not broadcast. Now you have seen the changed behavior. In case of hub, request was also a broadcast and reply was also a. But in case of switch, request was a, but reply was a. Now see, this time switch is having both the entries. This time switch is having. Now A has to communicate with C again. A will send data to the switch. Switch will say, yes, I already have an entry for A in my table. Now switch will check destination MAC address. Destination is C. C is connected to which port? It means this time it will never go. It will go. It means we can conclude here that switch will only broadcast in two cases. In two cases. In two cases. Stop here. In two cases. One, when I am receiving some data and I don't know about destination MAC address, at that time what I will do? Broadcast. Second case, the traffic which is coming from the user, it is a broadcast traffic. It is a. Now there will be a question in your mind, sir, which traffic you are talking about? Guys, ARP traffic. When ARP is generated by user, that ARP is always broadcast. Agree? When user will generate a ARP, it will be received by switch. What switch will do? Guys, just try to understand a simple thing. पहले हिंदी में फिर इंग्लिश में. मैं इस switch को ऐसा क्या बताऊंगा जिसकी वजह से ये मेरे उस particular data को क्या समझेगा? Broadcast. You are getting my question? My question is, switch काम कैसे करता है? How switch works? First of all, switch will check the source MAC. Then switch will check the destination MAC. If destination MAC is not present in the table, it will broadcast. Fine. But we know one thing. If I am sending a R, if I am sending a destination MAC address is never specified because I don't know about destination MAC address. In that case, destination MAC address is all F. Destination MAC address is all F. Agree? Now, when let's say A has to communicate with E. So what A will do first of all? A will generate R for E. Let's say 10001, 10005. 10001 will generate R for 10005. Source IP will be 10001. Destination IP will be 10005. Source MAC will be. Destination is not known. So I mark destination MAC address as all F. When switch will receive the traffic, first thing, switch will do the same thing. He will check the source MAC and make an entry in its MAC address table. If switch is already having an entry, it will check directly destination MAC address. Destination MAC address is all F. When switch finds destination MAC address as all F, switch knows. It means what I have to do? Broadcast. What I have to do? It means switch will broadcast in two cases. First, computer is generating a broadcast and switch is broadcasting that broadcast. Second case, switch does not know about MAC address. Destination MAC address is not present in the MAC address table. At that time also what switch will do? Broadcast. Any issues? Anybody? Clear? बिल्कुल. Benefit देखा आपने switch को use करने का? You have seen the benefit of using a switch. Now the main thing is of MAC address table. If I have a permanent MAC address table, there is no need of broadcast. But still, switch will broadcast. Why? Because the user will not because the user will not stop generating ARP. So, if you want a stable network, your ARP table must be your ARP path table must be stable and your MAC address table must be stable. This thing is clear? This thing is fine? Fine. Next device is router. Guys, if I say this is a switch, it is connected to a hub. It is again connected to a switch. It is again connected to a hub. Here is one user. Here is one user. They have to communicate. Will they communicate? Yes or no? Yes. There will be any problem? No. Why? Let's say this is port number 1, port number 2. Port number 1, port number 2. This guy is 10001. This guy is 2. MAC address is A. MAC address is B. I am just showing you the flow. Fine. From here, traffic will be sent. Source MAC will be A. Destination will be B. But I am starting with destination will be all F. He will send the data. It will be received by hub. Do hub maintain any table? No. Hub will? It will be received on which port? Port number 2. Switch B. Switch A. This is switch A. This is switch. Switch B will maintain an entry that on port number 2 a device is connected whose MAC address is A. Any issue? Now switch will check destination MAC. Destination MAC is all. What switch will do? It will be received by hub. Hub will. Now switch A will also make an entry on port number 2. There is a device connected whose MAC address is A. Any issues? Now what switch will check? Destination MAC, and switch will also broadcast. Agree? Now it will be received by this guy. What this guy will do? He will reply. Source will be. Destination will be A. Agree? It will be received by switch A on port number 1, who is connected? B. Now switch will check destination MAC address. Destination MAC is A. Destination MAC is A. A is connected to which port? Switch will not perform broadcast. Switch will perform unicast. In between two switches we have a hub. This guy will perform broadcast. Agree? It will be received by switch B. Switch B will say source is B. To port number 1, one device is connected whose MAC address is B. Any issues? Destination is A. A is connected to port number 2. He will send data out of port number 2. Now it will be received by the user. This thing is clear. After this MAC address table will be built, switch will always perform. It will never perform broadcast. So this will be the flow. What is the main thing here to notice? Switch B is learning the MAC address of the user who are connected to switch A. See, the user is connected to which switch? A. His MAC address is B. His MAC address is B. B is learned on this switch or not? Yes. B is learned. This thing is clear? So, what I was discussing about? Flow. This is how devices in the same broadcast domain will communicate. Right? इस तरह से communicate करेंगे वो device जो किस में होंगे? Same broadcast domain में. अब अगर मैं if I will give you 5 switches and I connect users to them, you can decide the flow. What will be the flow? Fine. कोई issue आएगा आपको? You will get an issue? No. Now, most important thing, guys, what you are studying? Guys, what you are studying? CCNA routing and switching. So today I will tell you the meaning of switching. What do you mean by switching? Switching means switching packet from switching data from one interface to another. Guys, what I want to say, try to understand that if in this room there are two doors, if you will get into the room from this door, you will travel through whole room, you will go to that door and you will leave the room. It means you have to travel inside the room. Agree? But there is nothing like traveling inside a switch. What I am saying, data is received on port number 2, data will never travel through the switch. ऐसा नहीं होगा कि switch के बीच में से क्या travel कर रहा है? Data. How switch will work? Switch will receive data on one interface. Switch will send copy of same data on the outgoing interface after checking MAC address table. क्या बोला मैंने? Switch will receive, switch क्या करेगा? Switch एक interface पे receive करेगा data को. मैंने आपको बताया switch के अंदर कभी data travel. तो switch का काम क्या actually? MAC address table check करके outgoing interface find out करके outgoing interface ही find out करता है switch. Agree or not? Yes, sir. Outgoing interface find out करके same data को उस interface पे क्या कर देना? Copy. Copy से भी एक बहुत अच्छा word याद आता है मुझे, replicate करना. What it can do? Replicate. Fine. किसी के माइंड में ये क्वेश्चन तो नहीं है what will happen when switch will broadcast? So replication will be on all the outgoing ports except the receiving port. Clear? So what switch is actually doing? Switch is switching traffic from one interface to another. Clear? Any issues? Anybody? So this is how switch will work. Switch is having one broadcast domain and one collision domain. Am I right? No. Every port has its own collision domain. Fine. Next device is router. Yes.
Sir, if the hub is having multiple users,
Yes.
then every changes in the MAC address will be happen.
Very good question. I appreciate your question, my friend. Now they will get to know. They will get to know about a new thing, which I actually missed. Fine. Now, guys, what is that thing? Try to understand. Here is one more guy. Here is one more guy. His MAC address is X. His MAC address is Y. On this particular port, X will be also learned and Y will be also learned. Agree or not? See, when X will send the data, source will be X. When it will receive on this interface of switch. Okay. We will draw it like this. Switch, hub, user A, user B, user C. Port number 1. MAC address table. Fine. Now switch will say, on port number 1 who is connected? A. On port number 1 who is connected? On port number 1 who is connected? C. This was your concern. It means switch can learn multiple MAC addresses on the same port. यार जो आपका एड्रेस है फिजिकल, वही आपके पापा का, वही आपकी मम्मी का, वही आपके भाई के, अगर दादा दादी भी साथ रहते हैं वही उनके. तो एक सेम एड्रेस मल्टीपल लोगों का हो सकता है. दिस थिंग इज क्लियर. इट मींस स्विच कैन लर्न मल्टीपल मैक एड्रेसेस ऑन द सेम पोर्ट. देयर इज नो इशू. दिस थिंग इज क्लियर. कोई प्रॉब्लम आएगी इससे? देयर विल बी नो प्रॉब्लम. सिर्फ एक इशू आएगा. MAC address table will be large. बट देयर इज नो इशू, कोई प्रॉब्लम नहीं आएगी इससे। फाइन, समझ में आई ये बात? राउटर आई डिस्कस करने मंडे को, मंडे तो यार क्लास आज हो नहीं पाई ढंग से।